exploratory data analysis. Okay, we can analyze CSV, Parquet, JSON, connect to Cosmos DB. We can extract schema information, and we can write SQL queries over that data. And we've got a logical data warehouse in which we can connect to Azure storage. We can connect to Data Lake Gen 1 and Gen 2, and we can cast structure over that data. We can persist objects and schema definition within a serverless SQL Pools database. And finally, data transformation, in which we can just use the serverless SQL engine and the available SQL syntax to process data and pass it on to the client process that's calling serverless SQL Pools. And we're going to be looking at the logical data warehouse. So can serverless SQL actually support creating a logical data warehouse? So my icons have appeared first, but essentially serverless SQL Pools is a SQL-based engine within Synapse Analytics. We can read data from Azure Storage and Data Lake Gen 1 and 2 and Cosmos DB. But there's no data. No data is actually stored within the serverless SQL pool. Dedicated SQL pool, yes. It used to be called the Azure SQL Data Warehouse. Dedicated is where the data is being imported into its database structure itself. So there's no data stored within serverless SQL pools. We can actually use serverless to write data back to the data lake. That process is called CTAS, create external table as select. We'll see that in a minute. But within serverless SQL, we have familiar objects. We can create a database. We can create stored procedures. We've got access to data management views. And the cost model is based purely on the amount of data processed, not compute, not length of time, purely data processed. So for example, if you run one SQL query that aggregates 1 terabyte of data in your data lake, that query, it has a dollar value attached to it. At the moment, it's around $5 per 1 terabyte. That includes reading and writing. Okay, important consideration. So when we're setting up the Azure infrastructure, we're looking at creating a database. We can create schemas to logically separate our objects that we're creating in that database. And we have authorization. Okay, so with authorization, this scenario is using Active Directory in terms of when I log into Synapse Studio and I run a query against the serverless SQL engine, my identity will be passed down to Azure Storage, and if I have permissions, I'll be able to read that data. We create a connection to the data lake, which is the DFS URL. If you go into your Azure portal and you look at your storage account, you'll see a few different URLs for different service types. The data lake is what you need for connection. And then we need to tell serverless, well, what are the file formats that we're going to be using when we're reading data? We can create Parquet file format, and we can create a delimited format in which we're telling serverless, well, how is my data delimited for a certain source? Now, we've got our data in the data lake. We've created our objects we've created our database in serverless SQL pool. Now we want to select data. Now we can just run a select statement using the open row set command and pass in the location, the data source type, etc. We can also create a view. So that means that anybody who's got authorization to connect to that SQL pool database and they'll see a view, they can query that view, well, just like any other SQL view, but the data is still stored in that data lake. We can do the same for the fact data. Okay, so we're going to create a view, and this is the source view that will feed our fact data. Okay, important thing to note in the sales order view here is that in the bulk command, we've got some wildcards: order year, order month, and order date. The first three. Ignore the CSV because I'm just picking up all CSV files within the folder. And what that means is I can expose those wildcards in the file path function. So that select file path 1, 2, and 3 actually points to those wildcards. So file path year will return the folder name, which will be the year, the month, and the day. I can use that to not only select, but I can filter on that as well. And that's the crux of the partition pruning process. So when we're looking at the dimensional model, hey, it's a process that's existed for many years. I get involved in many discussions on Twitter, and you see so many articles that are written about the validity of the star schema and the dimensional model today. I think it's more relevant than it's ever been to go through that modeling process of what do I want to measure and how do I want to measure it. Okay. And what we'll be doing is we'll actually be creating a star schema structure using serverless SQL pools. And we've got a couple of different types of data that we want to group in the dimensional model, which is dimensions, i.e. your reference data, and facts, the measurement. Now, Microsoft have got a best practices document for serverless SQL pools. And I believe I've got a link to it here. If not, I'll tweet the link out. And it's just a single page. And it's got some great recommendations in there about co-locating storage accounts, about data types. But one thing that caught my eye was a data type reference that said, use integer-based data types if possible in your sort, join, and group by operations. Now, where have I seen integers before? Surrogate keys in a data warehouse. So I thought, great. So I can take my source data, I can use serverless SQL to transform that, and I'm going to generate surrogate keys. So for the initial dimension loading, I've got my CSV data in my data lake. Okay, I created a view to select from that stock item from that CSV data. And now I'm going to create an external table which will allow me to write that select statement or the result of that select statement out to that location in the data lake. So as you can see, I'm using a location called conformed, dimensions, dim stock item, because that's my dimension. And I've got another folder called 01. I'm not discussing that in this session, but that's to do with slowly changing dimensions. Part 3 in my blog series talks a little bit about slowly changing dimensions. And what happens is the result of that will be written out to the data lake as a Parquet file. Now, it's important to note that serverless SQL has not stored any data itself anywhere. It's taken that CSV data from the data lake, processed it in its engine, the Polaris engine, and pushed it back as Parquet. Now, the reason that we're using Parquet is because it's a column store binary file format that supports filter pushdown. So when you write a where clause, it'll actually push that where clause down into the Parquet file and also only select the columns that you select. Now, for the fact loading, we're doing the same thing. We're creating that external table, okay, to take the data from the data lake and write it out, okay. And again, that'll be written out as Parquet. Now, again, I'll point you to part 3 in the Logical Data Warehouse blog series, in which we actually look at loading data from date folder to destination date folder to keep that partitioning structure. Now, reading the dimensional data, we're going to use a view, because the create external table statement, yes, it's created that external table, and yes, you'll be able to query that external table, but I'm using that process, that external table, simply to write the data out. I can drop that external table. It doesn't drop the data. It doesn't drop the folder. So I'm now creating my dimension view to select it from the folder that I've written the data out to. I'll do that for my stock item dimension, dim date, and fact sales. Ultimately, I'll then be able to join these views together and get my results back. So I'm going to jump back into the considerations, because I would like to run through a live demo so you can see what's happening. So let me flick to Synapse Studio. I hope you can all see that okay. Okay, so we're connected to built-in, which is our serverless engine. When you create an Azure Synapse workspace from scratch, you will automatically have a built-in, a serverless SQL pool. Okay, it's all automatic, so it'll be available when you create your Synapse Analytics workspace. And we can create a database. Okay, it'll be a few seconds to do that. And as we've said, we've got connections to our external data source. Okay, so we're going to have a little look at the use database, and we'll see we've got data TGIF. We'll create our location, which is the URL to the data lake. And we're just going to create the Parquet file format and the schemas. So we're going to create LDW, Logical Data Warehouse, and we'll do the same for stage, for my external tables. And we'll run an alter database command to support UTF-8 within the database. And the last thing is the credentials. So how is Serverless SQL going to connect to the data lake? What credentials are we going to use? There are several ways of doing this. We can use managed identity, or the user identity, or SAS keys. So now we've created our database, our connection to the data lake, our Parquet file format, schemas, and credentials to pass through to the data lake. We're going to create our source views. Now, we're not going to go through every single view here, but suffice to say that if we look at the syntax of one view, it is pretty much the same for all the other views. It's just pointing to a different location. So we're going to create a view, and we're going to select all from this location. So that's where my source system has dumped out its data for me to go and get. I've told Serverless what URL I want you to go and get it from, the format, does it have a header row, the field terminator, and this parser version. So currently 2.0 is the more performant way of connecting to delimited text. So if I run those commands, and what I'll do is at the bottom, okay, we've got a view for our sales order and our sales order lines, because we've got a header and a line item in our source data. And I'll just do a select top 10 all from, and let's get some data from sales orders, okay? Because I'd like to show you the results of these file path operations. So I'm going to select top 10. Okay, and we've got the columns that are in the source CSV. However, on the far right, we've got 3 extra columns: file path year, file path month, and file path date. Okay, so what I'll do is, what time is it? We've got a good few minutes. I'm going to go to the monitor tab, and I'll be very honest, I'm obsessed with the data processed metric. I wish to reduce that data processed as much as possible. And what you can see is we've got this data process metric that will show you how much data Serverless SQL has touched, processed, read, and written. And this is ultimately how you get charged. Now, at the moment, there is a minimum per query of 10 meg. Okay, so that's a consideration. Now, we've got our views. So what I'll do is I'm going to click the Data tab, Workspace, expand my list of databases. And if we expand views, then we can see we've got all the different views to make my stock item dimension, but also my sales orders to make my fact as well. Okay, so bearing in mind, this is simply a view over that source CSV data. Now, it's perfectly reasonable that you simply end your development work there. You don't have to write it out, Parquet, or create facts and dimensions. If you have source telemetry data, if you've got any data that's in a data lake that you feel is of benefit to simply cast views over that source data and use that for your analysis, brilliant, happy days. But I wanted to push it a little bit further to see what Serverless could do in terms of writing data out. So we're going to look at this create dimension script. And if we go to the Data Lakehouse storage account, okay, you can see that we've got our folders that contain all our source CSV data. So our operational system's written all the data out here, or we've gone and got that data. But I'm going to create an external table. I'm going to write it out to a new folder with the results of this select statement. So I'm going to use a row number to generate a surrogate key. And then I'm joining all my source views together to denormalize, to create a flat structure for my dimension. So I'll run that. While that's running, we'll go back to the storage account. We'll refresh a couple of times. There we go. And then we can see in our folder, we've got our Parquet file. Okay. Now, currently, we've got no control over the naming convention of the Parquet file or how many Parquet files are created. So if you have a large data set, multiple Parquet files can be written. I have a blog post on serverlesssql.com, which is called the 10 billion rows. And I go through how many Parquet files and how many rows per Parquet file are there if you wanted to have a look at that. But ultimately, there's our data. There's our transform data. But importantly, I'm not going to use the external table to query that data. I can drop that table. And in fact, let's do it now. So we're going to just take this. Okay. So we actually no longer have that table to query from, but the data still exists. I want to go back and create a view to query my dimension data. Okay, now note that I've got a wildcard. So even though I've saved it to this 0.1 directory, it doesn't really care that it's in 0.1. It's just going to get all the data. Okay, as I said, a slowly changing dimension pattern to add new and updated data can come in to those subfolders 02, 03, 04, etc. And I'm going to create a view over my date data, which I've kept in a CSV. There's no reason to transform that data because it's a very small data set. So if we refresh, we've now got our dim date view, we've got our dim stock item view. The last thing we'll do is our facts. Same process, we're going to create an external table. Okay, for the purpose of this session, kept it simple, and there is an initial folder. However, we can also write it out to a date folder and select only that specific date from our source data to populate, if you can imagine, a folder structure of dates. Keep it simple, we'll get all the data. Okay, joining our views together to get our keys, our degenerate dimensions in terms of order ID, and the columns that we want to be our measures. And again, I'm going to cast a view. I'm going to create a view over that data. And we can see fact sales. Okay, so there's our 2-dimension tables and our fact sales. Ultimately, what do we want to do with that? We want to query. What do we want to join those tables together, or views rather? So we'll do a select. We'll get the day name of the week. We'll get the stock item color name and the quantity by joining the fact sales, the date dimension, and stock item together. So we've now got a result to our query. So if we go back to the lake house, go to conformed, you can see we've got facts. Okay. Now at the moment, for this session, we've got an initial folder there, but in the blog series, we look at how we can dynamically write data out to the data lake folder and partition by year, month, day based on the source data. And this is now ready to be connected to within Power BI, or any other business intelligence tools are available, of course. So I'm going to flip back to the slide and just finish off, because there are some considerations. Okay, as I said, the cost model is based on the amount of data processed. So your scenario with your data will be different to somebody else's. So it is a case of looking at, well, how much source data do I have? How do I want to analyze that? Do I want to use serverless to write that back out? There's no caching of the data retrieved. Now, this is an important point because there are other, other vendors where something like this has been implemented. So if you run a query, let's say an aggregate query to analyze sales by date, no source data has changed, you run that query again, you will be charged for whatever data has been touched in that query. And lastly, this process is sort of immutable, so you can't run any SQL update statements or delete statements or insert statements on your data. It's all to do with either reading that data using select or creating an external table to write it out. So if anyone's familiar with the Delta Lake technology, which is the ability to use CRUD statements, updating and deleting data that's in a data lake, support for things like a merge statement. At the moment, Serverless SQL doesn't have this included, so it is a consideration. Lastly, the Logical Data Warehouse blog series. So there's 4 posts that go through the process of setting up a logical data warehouse, all the way through to connecting Power BI to that model. I would say personally that post 4 was the most interesting, because when we're looking at partition elimination, when we're looking at filtering data using dates, how is that passed down to Serverless SQL, and how does Serverless SQL then know to only select data from specific folders and therefore reduce data processed? So I went through a bit of a journey on that. And then lastly, some references and further reading. There's the official documentation from Microsoft. Yes, I am pointing to a Databricks URL for the Lakehouse, and some Parquet file format definition. And there we go. I thank you very much for listening. I'll hand back to you, Kay.
Sandy. It was very interesting. There was actually a question in the audience. I'll just be opening the microphone for it. So you have some more minutes to answer this question.
Yeah,
if
let's
anyone
go.
else, if any, I think,
well,
Chris, you have to activate your microphone yourself. I think you can't open it from here. So it just can mute it. Yeah. Okay.
Okay, great. Hi, Andy. I'm not sure if the last bit changes my question, the bit about there being no CRUD ops. But I was going to ask, how if you append rows to a dimension in a future run, how are you generating the surrogate key? And I guess if you can't do an append, are you just doing a full refresh?
No, not a full refresh. So actually, your answer is in your question as well. So as you can see here, I'm basically getting the max key from the current dimension view.
Oh, perfect.
And I'm basically going to append that to the row number when I generate my new rows and my updated rows. Okay, so the process of constructing a slowly changing dimension type 2 using purely Serverless SQL. Okay, now bearing in mind this really was seat in the pants. Like, should we really do this? Can we really do this? Well, you can. Maybe some simple dimensions if you had telemetry data or event data, but because we're writing out, if we're lucky enough in our source system that we do have some kind of valid from date, i.e., some last updated field or something in our source data, we can use that as our valid from date. If we don't have anything available, then we might just have to use the date the process was run. However, we've only got one column. So as you can see here, the supplier name, Graphic Design Institute, they did actually change supplier. So they changed from novelty goods supplier to a toy supplier. But the business have stated, Andy, we need to track those changes over time. Okay, we can't have it that if we run analysis that all of Graphic Design Institute sales are immediately just going to appear in toy supplier. But what we do is, yes, we generate, a new surrogate key. We've got our valid from dates that's grabbed from the source system. And then we create a view which uses a lead function and basically partitions by the business key. So ultimately what you end up with is a valid from and a valid to with an active member. Okay, But as I said, this was, this was the sort of the pushing the envelope in terms of, creating a view to be able to cast or to be able to track those changes over time in the dimension. What hasn't been addressed yet is things like any deletions. Okay, so that will probably be up for discussion. But ultimately, the loading the facts into, and if I scroll down a little bit here, let me just shrink that. Now, at the moment, the create external table command, we can't parameterize the location. So the location has to be a string within the syntax. So we're not able to parameterize that just in the regular create external table. So we can use dynamic SQL. It's a perfectly valid construct as per the Microsoft documentation and validated with a consultancy as well, where we can pass in a date. Okay, we're going to generate our location in the data lake that we want to store that data, and we can actually use that same date to grab our source data as well, and then write that out to the data lake. So if we do need to delete and reload any fact data, then as long as we've partitioned it, yes, we'll be able to do that. But it's got the same issue as any data warehouse, that if you have to regenerate dimension keys, you'll simply have to regenerate the dimension keys and reload the data. So I hope that's answered your question.
Chris, I think you have to unmute yourself again.
Yeah, it did. I'll have a follow-up question, but I know there were a couple other people that raised their hands, so I want to give them a chance first.
Yeah, well, you just tweet out the questions to me. I'll be more than happy to dive in and have a look.
All right, will do. Thanks.
Okay, this was amazing. Thank you. Anyone else a question? I'll have 2 minutes more. If this is not the case, I think we will start the second part of this session now. I'll stop the recording now as well. First.